Hello, everyone, and welcome to part 2 of 5 for the Work Zone Traffic Control and Safety webinar series. Part 3 will take place this afternoon at 2:30 p.m. Eastern Standard Time. My name is Paula Hyman from the Ohio LTAP Center, and I'll be your technical support for today's webinar. Just a couple housekeeping items. If you have questions throughout the presentation, go ahead and type those into the questions box, and our presenter will address those questions periodically throughout the presentation. This webinar is being recorded. Providing that the recording is successful, the YouTube link will be emailed to all participants and uploaded to our LTAP website at the conclusion of the series. I want to thank you in advance for your participation. And with that, I'll pass things off to Mr. Ray Brushart. Ray?
Thank you, Paula. Good morning, everybody. Ray Brushart here, ready for part 2 of our Work Zone Traffic Control and Safety course. I think I need to make a correction there, Paula. I think that this afternoon's session might begin at 1 o'clock, not 2:30. Maybe let's check what the maybe what the flyer says on that.
I'll check it and put it out in the chat box for everybody.
All right, thanks. So part 1, we ended up around this slide here where we're talking about some of the requirements for our advanced warning signs. We got to the part about the spacing of our signs, and we have this nice chart that was developed as part of the you can find it in the temporary traffic control manual, and also on page 17 of the little green booklet that's called Guidelines for Traffic Control in Work Zones. And we also have an app that you can download based upon the guidelines for traffic control in work zones. And we noticed that it was not on Google Play anymore. So we've made some phone calls, and that will be back up on Google Play for you to download for free very soon. So the requirements for advanced warning sign spacing depends upon the type of roadway you're on. So if you're on a 2-lane rural road, then those signs need to be 500 feet apart. And when you're in a village or a city, in an urban setting, low speed was at ODOT. We use 40 miles per hour and below as our low speed, and so in those urban areas, your signs can be 100 feet apart, like the typical 35 mile per hour speed limit sections or 25. And then those urban roadways that are 45 and higher, the signs would be 350 feet apart. And then when you get up to the freeways and expressways and freeway lookalikes, then the A, B, and C have different values. 1,000 feet, 1,500 feet, and half a mile, 2,640 feet. So that's how we determine our sign spacing. And it's all based upon the speed, how fast people are traveling. If you're on a 2-lane rural road, if you're going 55 miles per hour, that's around 80 feet per second. And then 60 miles per hour is 60 feet per second. So you have to think about those things when you're out there working, especially on those dangerous 2-lane roads that are curvy and hilly. So it's just, you never want to, if you're working on those roads, you don't want to think about not putting out any signs. Okay, so those signs are required because if you think about it, if you're on a 2-lane rural road, there really is no room for error for the motorist. They need to stay in their lane. If you leave your lane of traffic on a 2-lane rural road, you're either in a ditch, or you hit a tree or utility poles, or you're left of center and you can hit oncoming traffic or go into the ditch on the other side of the road. So let's think about those motorists and ourselves to provide as much safety as possible. And we do that with the number one way is provide advance warning properly. So we had talked about the requirements for the height of these signs, whether it's post-mounted or portable signs. Portable signs need to be a foot above the traveled way on a stand. So this is a picture of a nice looking sign there. It's meets all the requirements on the stand. It's even got, it exceeds the requirements. It has the flags on it, because if there's a way to enhance the conspicuity of the sign, draw attention to that sign, and let's do it. Another way to do it is to put your newest cone right beside the sign, not in front of it, but beside it. The shiny orange with the two bands of retro reflectivity can draw attention to the sign as well if you don't have flags. I think we ended up on this slide right here last time. So we were talking about, what are the problems you see in these pictures? And, the easy answers would be the signs are not spaced right, and the sign is on the ground in both pictures. That's not good. But if we want to talk about the picture on the left there, this is exactly the scenario that we do not want to see ever on our 2-lane rural roads in Ohio. They put themselves in a really dangerous situation here. So they don't have the proper advance warning. They don't. We talked about this is a busy road. This is not a low volume road. It's definitely high speed, at least 45, probably 55. And so we not only want the 3 signs that are shown in typical application number 10, but we want to look at some of the options because it's high speed. And the first option you get in flagging is to add the 4th sign that says "Be prepared to stop." And there's the buffer space you don't want to forget about as well. And so if you're going to be in a flagging operation in this stationary position like this, we want you to beef it up. I know our ODOT district offices, county garages, they've been trained for our 55-mile-per-hour 2-lane state routes to always have that 4th sign in the buffer space, things like that. So, and the cones, the good cone taper that's shown in typical application number 10. But we'll get into all that in part 4 of our series here. We talk about flagging and mobile operations. So the height of a sign in a work zone of post-mounted is basically the same as the permanent signs you would see in cities and villages. We see a stop sign here that is definitely on an urban street because we see the sidewalk and curb and gutter and on-street parking. Looks like a multifamily house there. So the bottom of that stop sign should be 7 feet above the traveled way. Same as a post-mounted sign in a work zone in an urban setting. Another thing about our signs is we need to maintain them properly. That's what the manual says. It has a whole section on sign maintenance. It says that signs shall be properly maintained for cleanliness, visibility, and correct positioning. And signs that have lost significant legibility shall be promptly replaced. We take a look at the sign in the picture. I don't know what that says, so it needs to be promptly replaced. That's how it works. How about this one? These signs here, they have definitely seen better days and they do not meet the current requirements, so they need to be replaced. How about signs used at night? Sometimes we have to do our roadway maintenance activities at night. You'll see a lot of ODOT projects, especially on our really busy roads and interstates around cities especially. We like to do a lot of our work at nighttime because there's less traffic and less inconvenience to people. But the signs we use at night, they're basically the same signs we use during the day in the typical applications, but they need to be retroreflectorized or illuminated. When I say retroreflectivity, it means that the light from the headlights, when they hit the sign, they bounce back. No matter what angle that they hit them on, they bounce back to the source of the light. It's very important. And so that's what this slide is showing, the difference between reflective and retroreflective. So here we have that's not my car, that's Magnum PI's car we're going to use as an example. So I think Kelly Wessels is in class. He's probably the only person maybe that remembers Magnum PI. But anyway, here we demonstrate that the headlights hit the sign and bounce right back to the source. And you know, within the last 10 years, the standards for reflectivity have been enhanced. And so the signs, the new signs are definitely very bright at night when the lights hit them. And so there's the difference between, on this slide, is a sign that's retroreflective and one that is not. So basically your signs disappear at night if they're not retroreflective. So that's enough about our signs. If there's any other questions about signs, you can just type it into your chat box. So let's move on and talk about our channelizing devices. So these are our devices that we use to direct traffic from one lane to another. They guide travelers along a safe path, but they themselves sometimes can be hazards themselves, like our barriers and barricades. Sometimes we need to put up warning signs for certain devices, and they are retroreflectorized for night use as well. Let's take a look at some of our channelizing devices. So we're talking about our cones, and there's different types of cones. We have tubular markers. We have vertical panels, drums. Drums are the orange barrels, or the Ohio State flower that is about to go into bloom here soon. And then we have barricades. We have different types of barricades. So let's take a look first at our different types of cones. These are definitely the most common channelizing device used in short duration operations, which is basically what our roadway maintenance activities consist of most of the time. They're meant to be used when you're out there for 12 hours or less, and they are meant to be attended. So if the cones are out there, you should be out there. And so there's a lot of advantages to cones. They have minor impedance to traffic, little effect on capacity, will not damage vehicles that hit them, well recognized and understood, as long as people see them, right? And easy to transport and store, but there are some disadvantages. They're not formidable. They don't scare the people that as much as the orange barrels do. And that's why when I was working at the city, if we were working in the downtown area, we did not use cones. We used drums in the downtown area. So that's something to think about, because you don't just want the vehicles to respect your devices, but you know, in the downtown area, you had pedestrians and bicyclists and things like that as well that you wanted to keep out of your work zone. So it's easy for vehicles and pedestrians and bicyclists to get into your work zone, and it's easy for these devices to be displaced or knocked over. And there's different types of cones with different heights. So, you know, there's 18-inch cones for daytime low speed roadways, like maybe in your residential neighborhoods. That would be the only place that I would use an 18-inch cone. And then there's our 28-inch cones. That's the cone that most people are more familiar with, like the ones in the picture there, the 28-inch cones with the two bands of retroreflectivity on them. Then we have what's called our grabber cones, more tubular, 42 inches in height. So here's a picture of a 4-lane highway with cones being used as a channelizing device. You got your shoulder taper in front of the arrow panel, and then you have the long merging taper there. Here we have a nighttime picture. So are these first two cones that you see there, are they acceptable in this situation? No, they're not. So they're required to have they're required to be retroreflectorized with the bands of retroreflectivity. And then we have our drums, the orange barrel. So they command more respect than cones, more visible to motorists. There's more value there for the human eye to see because they're wider, and but they are more difficult to install and store. How about this drum here? Is it acceptable for use? Well, you might be thinking, well, it does have the retro reflective bands. Isn't that good enough? Well, no, it's not, because the shape is unacceptable. We need the people to the motorists to instantly recognize it as the orange drum, the barrel, so they know that it's definitely in a work zone. This is the shape that we're shooting for in our drums. But if we take a closer look at this picture, we'll see a problem there with those drums, and that is they're not in the proper alignment. They're not in a straight line, so that can cause confusion to motorists. So they might think that they're allowed to drive in where those drums are out of line. So you want to keep check on your drums and cones and make sure they are in a straight line. Then we have our barricades, and these are we use these more to outline construction areas or to close or restrict a roadway or right of way. And different types of barricades can be used to channelize traffic or to mark a hazard. And we can mount signs on these type 3 barricades that we use to close our roadways. So we have different types of barricades: type 1, type 2, and type 3, whether it be a single rail, double rail, or triple rail. And so the type 3 is what we use for our road closures. And the stripes on the barricades actually mean something. So not everyone knows that, but same as the stripes that you would see on maybe on a concrete bridge abutment. Okay, they're both the same in that they slope downward in the direction the traffic is to pass. So in this picture, traffic would be allowed to drive to the left of the barricade. And so let's take a look at some other ways to use these barricades with the stripes in mind. So the one on the left would show that the traffic can turn left or right in that situation. And then when we have the one on the right, that means there's no turn possible, we must turn around. So that's what we use. That's how your barricade should look when we're closing a roadway or street. And when we use barricades, we have to realize that they can damage a vehicle if the vehicle runs into them. So we want to weigh them down properly, and that is with sandbags, and the sandbags are placed at the bottom of the barricade. So with that in mind, is this barricade weighted down properly? So no, that is not a forgiving design, and that might leave a mark or come flying through the windshield of the car that hits it. So sometimes you can use vertical panels if there's not enough room for barricades. And then we have lights. So we use lights to make devices more effective. They draw attention to the devices and can supplement other traffic control devices. So there's different types of warning lights. A type A, which is low intensity flashing, effective at nighttime. Anytime we're using lights at night, we want to make sure they're set on low intensity. That goes the same with arrow boards. Type B is high intensity flashing, effective. You want to use high intensity during the day. And then type C is a steady burning light used for delineation. So what type of light would we use on this sign, type A, B, or C, during the day for the road work ahead sign? And we're trying to draw attention to this sign with the light. So since it's the daytime, that would be a type B light. That'd be a high intensity flashing light. And then sometimes in our typical applications, they refer to some high-level devices, and these are used to supplement other devices, mainly in heavy urban traffic and or very high-speed traffic, like interstates. You'll see these. There's arrow panels, portable changeable message signs, and portable traffic signals. Let's take a look at our arrow panels. What do they do for us? So we use arrow panels in addition to our signs and channelizing devices, unless maybe it's a mobile operation. So our arrow panels, they direct traffic into the proper lane, and we never use an arrow display to direct traffic into opposing lanes. So that's why we never use arrow panels in a flagging operation on a two-lane road. So if we take a look at our flagging operation, typical application number 10, we'll see our signs and a flagger and cones, but there is no arrow panel in a flagging operation. That would draw too much attention to the arrow panel and direct the attention away from the flagger. And the size of the arrow panel depends on the type of roadway you're on. So there's the 48-inch by 24-inch for two-lane roadways, like for mobile operations. And the high-intensity lights have a minimum of a half-mile visibility. And the larger arrow panels are used for multi-lane highways, 96 by 48-inch. And like I said earlier, when you're using an arrow panel at night or in bad weather, we want to have those set on the lower intensity because it can blind people. And if you're going to purchase arrow boards for your agency, we want to make sure you get an arrow board that's capable of all of these modes of operation. You got for lane closures, you got your arrow left, arrow right, or even the double arrow if you're working in the middle lane of a 3-lane section, it's all going one direction. And then we have our caution modes. So it's a straight bar or the 4 corners mode for for shoulder work, or also it shows the 4 corners mode for a mobile operation on a 2-lane road as well. So here's the 4 corners mode that is shown in typical applications number 4 and 6, which is shoulder work. So we don't want you to use an arrow if you're only on the shoulder, because too many motorists interpret that as the right lane being closed. And you know how it goes on a busy road. If one person gets over, they all get over. And that reminds me of what happened on I-70 out on the west side of Columbus one morning. I was living in Dublin, and it's one of the worst traffic jams ever that morning because there was a contractor that was on I-70 there between 270 and Wilson Road, and it was just a shoulder maintenance job. And first of all, the notes in his project told him that he was not allowed out there until after 9 a.m. and also clearly showed that, you know, he should only use the 4 corners mode and on his maintenance of traffic project sheet. And so but what did he do? He was out there about 7 a.m. and he had an arrow on, and so that was right in the middle of the morning rush hour. And so everyone interpreted that as the right lane was closed, and we need every lane of traffic there in the morning. And so it was the same thing as there being a crash or something, because there was, you know, one less lane of traffic, and there was right where it was merging and everything else. So both 70 and 270, as a result, were both a parking lot that morning. So here's a picture showing a mobile operation on a multi-lane road. And so in this situation, you can use the arrow mode. So they have it in arrow mode so everybody can go around this vehicle on the left. And so we also have our portable changeable message signs. And we can use these to display messages for unexpected traffic situations or rerouting. Or sometimes in heavy traffic, we'll use these portable changeable message signs to say the same thing as one of the signs in the advanced warning area, like right lane closed ahead or merge left or something like that. And then we also have portable traffic signals, and these are good for controlling traffic when both directions need to use the same lane. Like these are good for, you see these quite a bit on 2-lane roads that maybe there's a bridge project where only one lane of the bridge is open. And so since it needs to be out there 24 hours, 7 days a week, it's not like we can have flaggers there at all times probably. So these are good to use in those situations. But these signals meet all the requirements of regular traffic signals as well. So with our traffic control devices, visibility is key for both effective communication and safety. So you got to remember when we're putting out our traffic control devices that when we place them, we need to make sure that they are visible to the motorists. So we have some devices that help improve visibility, especially in mobile operations. And these are talked about in the notes page for the mobile operations typical applications. And we're talking about emergency flashers, flashing strobe lights, rotating beacons, and retroreflective vehicle markings. And so some of these are listed as standards in mobile operations. So that means you must have them on your flashing strobes or rotating beacons in certain situations. Other devices that may improve safety is fencing and steel cover plates. So the fencing I'm talking about is shown in this picture here. You see it's high visibility colors, and they're effective in keeping pedestrians and bicyclists out of your work zone. So these are good for cities and villages. And then you have your steel cover plates. So they allow traffic to safely travel over trenches or excavations that maybe you didn't have the time to close. Let me see, do we have a question here? I see a question about, I'm called something 10. I was referring to typical application number 10 in the temporary traffic control manual. In part 1, we went over how the typical applications are numbered from 1 to 46. And typical application number 10 refers to a flagging operation on a 2-lane roadway. So that's what I was talking about. So when we're using these steel cover plates, it's important that we warn the public that they're about to hit the steel plate. So when I was working at the city of Columbus, we had our own standard. Remember I talked about local standards, but our local standard was to put a sign in advance that says steel plate ahead. And then we would also put a lip of asphalt around the steel plate as well to help them get over it, to lessen the bump of that plate as well. And then sometimes in our maintenance activities, especially if it's going to last a few days, sometimes we need to alter the pavement markings on the roadway. And so pavement markings are also a traffic control device, and the different colors of pavement markings have meanings. So the white pavement markings, they separate traffic flowing in the same direction, or they mark the edge of the pavement on like the left edge of a pavement on a multi-lane roadway, or the white edge line on the, I'm sorry, on the right side of the roadway. White edge line, solid line. Then we have our yellow markings, and just like the signs, yellow means warning. And so this is what we use to separate traffic flowing in opposing directions, or marks the left edge of the pavement of a divided highway and one-way streets. As you can see in the pictures there on the right, the different ways to use the yellow pavement markings. So temporary pavement markings are needed for long-term jobs, so that means 3 days or longer. And the old pavement markings need to be completely removed so that a clear path is obvious to the motorist. So the way to do that is to obliterate the pavement markings. And obliterated markings shall be unidentifiable as pavement markings under day and night, wet or dry conditions. So how do we remove pavement markings? And the manual says, by any method that completely removes the marking and the glass beads and does not leave a scar that could be misleading. So we use sandblasting or grinding methods. If you do not remove the marking, what is your option? So overlaying existing stripes of black paint or asphalt is not permitted. However, removable, non-reflective preformed tape is permitted. So this picture here, they used black paint, so that is not allowed. So it says that right in section 6F.71. And here's an example of a kind of removed some of the pavement markings, but not really. So that causes confusion to the motorists. This section here, you can see. So that wraps up our lesson 2 on traffic control devices. And to summarize that, basically the best way to communicate a clear message to the motorists and all road users is to utilize our traffic control devices. They are extremely effective if used properly, and they help you make the work site as safe as possible. And in each typical application, they show you which devices to use in the picture, and then when you read the notes on standards, guidance, and options, they might suggest some other supplemental devices as well. And so we need to follow the standards for uniformity. So that's why we want you to use the temporary traffic control manual in your design of your work zone for that day. We don't want you just to come up with your own solution. We want everyone to be using the manual. Do we have another question? Is cold patch hot mix required around steel plates? The question is cold patch hot mix required around steel plates? I don't know if it's required, but I definitely suggest it. I know it was, like I said, when I was at the city of Columbus, it was our own local standard. So that is something, but here I live in Circleville, and apparently it's not a standard here at Circleville, because there's one right by the McDonald's. And also my wife was driving through there one night when it was snowing, and she was behind the snow plow, and she actually witnessed the snow plow crash into that steel plate. So anyway, I guess it's up to the local agency to come up with your own standard. I highly recommend it, but I know maybe sometimes it's an emergency and you can't get to it, but at least have a sign. There isn't even a sign that says steel plate ahead at the one here in Circleville. All right, so let's move on to lesson 3, elements of a traffic control plan. So what is a temporary traffic control zone, or TTCZ? So this is an area that where the entire section of roadway between the first advance warning sign through the last traffic control device, where traffic returns to its normal path. So it's all the way from the first sign all the way to the very end of the project, where traffic resumes to its normal driving. So here are the different components of a temporary traffic control zone. The first arrive at the advance warning area. Then there's a transition area where you're going to change a lane usually. And then you arrive at the work area, which consists of a buffer space, the workspace, and the traffic space. And then at the end, you have your termination area. So here we show an area here where it's basically a flagging operation on a 2-lane road. So let's first talk about our advance warning area. So every work zone or temporary traffic control zone has an advance warning area, even low speed closures and even mobile work zones. And if you had no advance warning area or no warning to the motorist, you run the risk of surprising the motorist, which results in them slamming on the brakes, going into some erratic maneuver, and then there's a crash. So I can't stress enough to have the proper advance warning area. So if we reflect back to the crashes we talked about in part 1, there was 6,581 crashes in 2019, 16 fatalities, and 129 serious injuries. Well, the majority of these crashes occurred because a lot of the times the advanced warning area was not set up properly. And so, like I said, we, as roadway workers or roadway designers, engineers, there's several reasons for a crash, but we do not want that reason to be us not providing the advanced warning area. So the size of our signs in the advanced warning area, there are standards involved with them, of course, and the temporary traffic control manual says that for higher speed locations, signs need to be 48 inches by 48 inches. And where speeds and volumes are lower, then you can use a 36 by 36 inch signs. And then they have smaller signs can be used on low speed, low volume, like residential streets maybe that are 25 miles per hour. You could use 24 by 24, but I would still use 36 by 36. Let's see, do we have another question? When we get to it, is a buffer space optional in certain situations? I'd have to say yes to that. So we'll get to buffer space here shortly. So this chart reflects the previous slide where we have requirements for the minimum sizes of signs in different situations. Okay, so let's take a look at some advanced warning areas on different types of roadways. And so here we have typical application number 33, which is all about a stationary lane closure on a divided highway. So you see the picture on the right, it's a 4-lane divided highway. And so in this situation, we have plenty of room for signs on both sides of the 2 lanes. So you see in the picture, you see the road work ahead signs are located on both sides of the roadway. And that's important in this situation because well, one reason is you can think about heavy truck traffic. If a vehicle, a regular sized car is in the left lane and there's a whole string of semi trucks in the right lane, they may not see all the signs that are on the right side of the road. So with a heavy volume traffic and high speed, we have the room for signs. So it's required in this situation that we put the signs up on both sides of the roadway, so you can see that on on the left side of the slide there. In this particular typical application, they show a difference, a slight difference between short term on the right and long term and intermediate on the left. And for our long term highway projects, you'll see that we have even shows a concrete barrier, or not concrete barrier, that's a temporary white edge line that was put in throughout the length of the merging taper there. You can see my arrows circling it. So that's a 4-lane divided roadway, and then here we have the 2-lane roadway. And so in this situation, you have your 3 advanced warning signs, and they're on the right side of the road only. So this is the typical application number 10 that I was talking about. Somebody had a question about that. So it shows your 3 advanced warning signs. It shows the flagger location. It shows a cone taper here, and it has the cones placed throughout the buffer and the workspace. And it has the end roadwork sign at the end. And if you read the notes page on typical application number 10, that's where you'll find the option and guidance for the use of the be prepared to stop sign as well. So when we place our signs in the advanced warning area, we need to give special consideration for several things. One is high-speed highways, sight distance issues like curves and hills, dips in the road, intersections and driveways, parked vehicles. With cities and villages, you've got your on-street parking that is not shown in any of the typical applications. And then, so you have to come up with your local standards on how you deal with that. Depending on the type of maintenance we were dealing with at the city of Columbus, sometimes we'd have our guys go out there the night before or very early in the morning and remove parking and restrict parking for the next day for us to be working in certain situations. So that would be one way to deal with the parked vehicles. The other one is sometimes commercial signs and existing signage kind of get in your way of where you want to place your temporary signs. So you got to figure out what to do in those situations. So let's take a look. So here we have a driveway or even an intersection, and you can see the workers place the road work ahead sign right there on the far side of the intersection, where every time a vehicle exits the drive or arrives at that intersection, they're blocking the sign. So you don't want to do that. So you want to adjust the location of that sign one way or the other so that the motorists can for sure see that sign. And then we have an urban situation here where you see some signs in different places. You've got the first sign is right in the middle of a sidewalk, which we don't want to do that. We don't want to block pedestrians. And then our second sign is about 10 feet high on a pole. So I think we need to be more consistent with the location of our signs so that the motorists don't have to work to find the signs. You want the signs to really stand out. And when I was at the city of Columbus, what we would do in this situation is we would actually attach signs to our orange drums sometimes, and then weigh them down in the drum and put them out there along the in this area here. if we had to remove parking for the day, we would do that. So that's how we dealt with that situation. Here we have a sign that was installed right behind a road marker. I don't know how this happened, but um, here we have, you don't want existing signs to block your signs. Obviously, you can adjust the location of that sign so people can actually see it. And then here we have a cluster of work zone and permanent signs. And so, your work zone signs don't really stand out here. So you want to do something else in this situation. Maybe you could put signs on both sides of the road, or use portable signs, or just to adjust the location of this sign as best you can so that it stands out better. So that was the advanced warning area, and then we have our transition area. So this is where in lane closures, where vehicles are changing lanes. And so there are different types of tapers. We have the tapers that are in this area here is called the emerging tapers, shifting tapers, shoulder tapers, and two-way traffic tapers. And then at the end, of the work zone, we have in the termination area, we have our downstream taper. So in the transition area, this is usually for a multi-lane roadway, it's usually emerging taper for a lane closure, where traffic is gradually moved from its normal travel lane into another. And it's usually marked by channelizing devices and or pavement markings, or both, depending on the time, the duration of the work zone. So here we have a typical 4-lane roadway. And so we'll call that westbound traffic. The westbound right lane, we need to move them from the right lane into the left lane. And the more gradual, the better when it comes to multi-lane roadways. So that's why the emerging taper is a pretty long taper compared to others. And its length depends on the speed of traffic and the width of the closed lane. So you can see the situation here where the red car, see the red car and the green car there on the left. So the red car needs some time to think about his maneuver. He has some concerns and issues, so he's got to, he's seen the signs, he sees the taper in front of him, and he knows he has to get over. The green car is to his left, so he can't get over right now. So he's going to have time to adjust his driving and speed to get over into that left lane. So he's slow down or punch it, right? So all this takes time and distance. So the merging taper is the longest taper we have. It depends on the speed and lane width. It actually has an algebraic formula of how we come up with the length of this merging taper. The length is equal to the width of the lane in feet multiplied by the speed of traffic in miles per hour. But for those of you that hate math like I do, you don't have to worry about that. We have a chart that has already done the math for you. But that's how they arrived at those values. So in a high-speed lane closure, how high is high speed? Well, it's not necessarily a fixed number. It may be subjective, it says, but at ODOT, we use 45 miles per hour and higher as high speed. But if you are in doubt, which a lot of people are in doubt when you get into the local level, And we assume, if you're really in doubt, we assume the facility is high speed. You know, there's a lot of speed limit changes in cities and villages and areas like that. We have to, as a worker in a lane closure situation, we need to realize that you know, you're in a potential where car crashes can happen, and we can create congested conditions. Congested conditions um, can result in crashes. So we need to really make sure we're following the correct procedures out there, um, even for low speeds, it says. So here's the chart I was talking about, and it's also on page 17 of the guidelines for traffic control in work zones, and it's also towards the beginning of part 6 of the temporary traffic control manual. But it shows the length of a merging taper according to the speed limit and the width of the lane. So as an example, at ODOT, we've got a lot of 65 mile per hour highways with 12-foot lanes. So in that situation, the length of the merging taper is 780 feet. And so if you look up the chart at 35 miles per hour and maybe a 10-foot lane or an 11-foot lane, you see it would be 205 feet or 225 feet. And so that's a big difference, isn't it, between 225 and 780 feet. So it's very important that we provide the proper length of the merging taper. So again, that's what we use for a lane closure on a multiple lane roadway. Here's a picture of a merging taper down in District 9, probably Lawrence County, 52 probably. So we have our drums for our high-speed project we're using here, and an arrow panel, but you know, that's probably 780 feet long. So then we have our lower speed lane closures in our cities and villages. And for low speed, you actually use a different algebraic formula to arrive at this. So it's the width of the lane in feet multiplied by speed of traffic in miles per hour, and the speed is squared and then divided by 60. And that's how we arrived at the values for the length of the tapers for low speeds. So 40 miles per hour or less is what we use for low speed. The types of low speed roadways, there's several. There's urban residential streets, suburban residential streets, low speed arterials, and streets within a central business district, or like downtown Columbus, that would be 25 miles per hour. And so here's the chart with the different values for low speed, the length of merging tapers and low speed. So as you can see, 35 miles per hour, depending on the width of the lane, might be 11 feet, so 225 feet. And in downtown, 25 miles per hour. You know, sometimes we have 11-foot lanes in downtown. Sometimes we have 9-foot lanes in downtown. Just depends. I think that in parts of Columbus, some of the left turn pockets in downtown are 8.5 feet wide. So. Okay, let's talk some more about the use of arrow panels in the merging, or the in the merging area, the transition area. Don't you hate it when you can't think of a word? I bet Kelly Wessels is laughing at me. Anyway, the use of arrow panels in a transition area. Sometimes they are required. Sometimes it's a judgment call, but we use them to direct traffic into the proper lane. If we're dealing with a roadway that has a shoulder, then we position the arrow panel on the shoulder at the beginning of the merging taper. But a lot of times we don't have a shoulder at the local level. We've got curb and gutter streets, things like that. So we position them inside the merging taper. And again, we don't use arrow panels to direct traffic into opposing lanes. Okay, so what do we have here? We have a picture showing, this is from typical, as we zoomed in on typical application number 33, and it's showing the position of the arrow panel there on the shoulder of the roadway at the beginning of the merging taper, and it's protected by the shoulder taper. And then here we have a situation where the arrow panel is located inside the merging taper because we did not have enough room on the shoulder for it. Okay, let's talk about where we're on a multiple lane road and we want to close more than one lane. So in this particular instance, we would have multiple tapers. And we do that instead of having one really long merging taper. So let's take a look at what I'm talking about. And there's a section in between each taper called a tangent section. So here's like a multiple lane freeway. We got 4 lanes heading in one direction, but they're closing the right 2 lanes. So as you can see, we have a merging taper. We have 2 merging tapers, and in between we have a tangent section that is twice the length of the merging taper. And we have an arrow panel at the beginning of each taper. So that's typical application 37. How about if we wanted to close 3 lanes of that roadway? If we wanted to do that, then we would have 2 tangent sections and then an arrow panel for each taper. And so if we threw in the speed limit so we could figure out the values of the merging tapers and the tangent section, we would see that for 65 miles an hour in a 12-foot lane, the length of each merging taper is 780 feet, and then the length of each tangent section is 1,560 feet. Then here's a situation where we have a 4-lane undivided roadway, and we want to close, in this picture, the 2 northbound lanes, for instance. We want to close both of them because we've got to close both of those lanes to fix something here. And so the way we do that is we close the right lane first with a typical right lane closure, an emerging taper, an arrow board. And then we have, depending on the speed limit, we're either using half L or the full value of L. And then we have a different type of taper. This taper here is not a merging taper. It's called a shifting taper. And we use these signs here that you see here on the right. They're called the shifting arrows. We're shifting them to the left, and then we shift them back to the right. We're actually shifting them into the southbound. If you're southbound, that would be the southbound left lane. So typically that lane is going the other direction. So we're not using an arrow panel there up here. We're using it here to close the right lane, but not here. And then the southbound traffic would have a typical left lane closure to put everybody into the right lane as they come south. And so they threw some values in here. What if it was a 45-mile-per-hour roadway? So then the length of this merging taper is 540 feet. And then at 45 miles per hour, you can use half L instead of L. I think 50 miles per hour and higher, you would use the full value of L. So it's kind of a judgment call to use half L or even exceed that a little bit. You know, in your judgment, you can always use the full length of L if you got the room for it or whatever. But it says you can use half L at 45 miles per hour. And then you have the shifting taper. And the shifting taper has a way to calculate it as well. So we'll get to that in a minute. So anytime we're dealing in a situation where we have a lane closure, we need to follow the fundamentals of visibility, warning, and control. So visibility, so all devices are visible. The signs, the channelizing devices, arrow panel. We need the proper warning so the public knows there is construction ahead to make sure our advanced warning area is installed correctly, and the proper control so everyone can maneuver around the site. Proper traffic control and the proper devices shown in the typical applications. So let's talk a little bit more about these typical applications. So there, like I said, there's 46 different typical applications. Each one covers the different variables you see in the roadway, from high speed and low speed and the number of lanes. And they're all shown in ideal conditions. And they all look a lot like state routes, state highways. And so if you work for a village or a city or a county engineer's office, you'll see that they don't quite look like your roadways most of the time. So we need to adjust the typical applications to meet our field conditions. So let's take a look here at the different lengths of time for each of our maintenance activities. So we have a short duration setup is where you're going to be out there for up to 1 hour. And in these situations, even though it's a shorter amount of time, you still face the same dangers. And so sometimes there's some judgment going on, engineering judgment. And then we also have the, you want to consider using some additional devices. And so I'm talking about changeable message boards maybe, and sometimes shadow vehicles equipped with a truck mounted attenuator. So let's take a look at some of these situations. So we have an interior lane closure on a multi-lane street. So it's a 4-lane roadway, and the northbound left lane and the southbound left lane are both closed. So this is from typical application number 30. So this is the picture that goes along with typical application number 30, and in it we see 2 signs and an arrow board, an emerging taper. They show the placement of the arrow board here. But then if we look at the notes page, we can see how to enhance this. You can place an additional sign. So you have 3 signs. You can always have the symbol of the left lane merging over. And then, of course, the addition of police officers with their lights on, or what else? Truck mounted attenuators, things like that. So there's things to consider to make it safer. Do I see a question over here? Let's see. Can you briefly discuss how to determine the work zone speed limit of a project that lasts 3+ months? Do you use the existing speed limit, or can you reduce it by 5 to 10 miles per hour for construction? And the answer is yes. And the manual goes into detail about how to lower the speed limit for these long-term projects. And this course here, I don't like to get into long-term because it's mainly for roadway maintenance activities for local governments. But something an operation is going to last that long. You're definitely going to have a series of planning meetings, and you discuss these things. But as you've seen ODOT projects long term, where we're most of the time we are lowering the speed limit through our long term projects. So there is a section in that in the temporary traffic control manual on that and how to do that properly, how to sign it properly in advance. And there's also been some new innovations on that as well that may not be listed in the manual, but you can obviously see some new ways to do that on some of the projects in the last few years, like on I-71 and 75 and things like that. And then here's a typical application number 32, where we have a 4-lane roadway and we're closing the 2 northbound lanes. And so it details the signage and the merging taper, arrow board, the shifting tapers, because we're shifting the northbound left lane into the southbound left lane. And it shows exactly how to close that southbound left lane at the top of the page. The use of flaggers for multi-lane roadway lane closures. We don't want to use flaggers. We're going to close those lanes with our different traffic control devices. So we don't want to put a person in that kind of a dangerous situation. There's a reason that roadway has multiple lanes. It's because of its high volume of traffic. And so in a mixture of traffic, commercial traffic as well, lots of trucks, etc. So we don't want to put a flagger in that situation. All right, here's kind of a funny picture. Obviously, it's not a recent picture, but it says, what all can you find wrong in this picture? So once you type some stuff into the question box about something that you might, maybe 1 or 2 or 3 things you see wrong in this picture. Here, I'll throw one out at you there. Up to the drum, the first drum you see is upside down. How in the world that happened? I don't know. Let's see what we got here. We have I see a barrel that looks a little crushed. I see someone wrote that. Pavement markings that are left over, old white lines, yeah. Okay. Good answers, good answers. What else do we see here? Pavement marking not removed. Drum with a distorted shape. And of course you have we frown upon seeing parked vehicles here in the transition area and buffer space. This area is supposed to be completely vacant of people and vehicles and equipment and materials, because it's there for the situation where an errant motorist might come plowing through there. So we want that area to be completely vacant. All right, let's talk a little more about a different type of taper, and that's the shifting taper that we saw in some of these typical applications. We use the shifting taper to shift traffic laterally into another lane or even on the shoulder. Usually it's either on the shoulder or into a lane that was going the other direction. And so at 50 miles per hour or greater, we use L, which is equivalent to the length of a merging taper. Or if it's less than 50 miles per hour, 45 or lower, you can use half L. So half the length of a merging taper. And the more gradual, the better, it says. So here's a situation. Typical application 36 is something you've probably seen quite a bit on around Columbus on I-270, on parts of 71 between Columbus and Cleveland, where at ODOT we've been beefing up the shoulders of the roadway in a lot of these places in case we wanted to use the shoulders to use as an emergency lane of traffic. And so to do that, like if we're working on the shoulder on the left side of the roadway, like you see in this picture, we don't want to lose capacity of the roadway. And so to do that, we'll shift traffic over a lane. And so the rightmost lane is actually driving on the shoulder for a while. And so if we follow these three vehicles here through this work zone, we'll see that we didn't lose any lanes of traffic in this situation. So that helped us, even though we're blocking the leftmost lane, we're shifting traffic over, and we're using the shoulder as a lane of traffic to help us do that. And so the length of these shifting tapers are either L or half L, depending on the speed limit. So here's a picture from one of these projects. Here we have the right lane closure for the southbound right, and then we're using a shoulder over here to run traffic on temporarily. So we shifted them over. And again, when you use the shifting, if you're going to use the shifting tapers, you got to have the shifting arrow signs to go with it. So in this case, we have a sign here with 3 shifting arrows on one sign because there's 3 lanes of traffic to shift back. And then another type of taper we have is the shoulder taper. So if you're working on the shoulder on a multi-lane road, or if you're closing the right lane and you want to protect the arrow panel, you can use a shoulder taper to protect the arrow panel, as you see in this picture here. And that's done with a shoulder taper. It doesn't have to be as long as a merging taper because there's no traffic theoretically on the shoulder to get over. So the length of a shoulder taper is 1/3 the length of the merging taper. So, and it says that right here. If you look on the left here at the typical application, it says 1/3 L is the length of this shoulder taper. So this is called typical application number 6 that deals with shoulder work with minor encroachment, it says. So minor encroachment, meaning that maybe the drums are actually encroaching into the travel lane, maybe by a foot or 2. And so this is an important typical application to put some thought into, especially at the local level. At ODOT, most of the time we're dealing with 12-foot lanes. So maybe we do have a foot or 2 to play with, and we can still leave that right lane of traffic open. But at the local level, we usually don't have 12-foot lanes. Usually it's 11-foot or 10-foot, sometimes 9-foot. And then, of course, in rural areas and township roads and some lower volume county roads, you're dealing with 8-foot lanes, 16, it's not even lanes, usually it's 16 foot wide for both lanes and no pavement markings and sometimes. So, and sometimes you don't even have shoulders to be working on in the first place. But when I was working at the city of Columbus, we would we had our own local standard on this. So if we had a shoulder we're working on and we were out into the lane of traffic, depending on what road it was, what type of road, was it an arterial or is it something less than an arterial? Um, then as soon as if it's an arterial street, if we got less than 9 feet, make so that lane would be less than 9 feet wide, then we would go ahead and just close that lane. We wouldn't use this typical application. We would use a different one where the lane was closed. So you have to put some thought into what will your standard be as far as how wide of a lane you're going to have left over for the traffic to drive in. Especially on a 2-lane road, you don't want to have a situation where you made the lane too narrow and they're getting over into the other lane and cause a crash. So you have to, if it's a roadway carrying commercial traffic, then maybe you shouldn't go less than 10 feet left over. Of course, at the local level, then you're just basically going to be closing that lane. But that's sort of some of the thinking you get into when you have to use typical application number 6. So here's a picture showing the shoulder taper, which is 1/3 the length of a merging taper. And then again, when we're using arrow panels for shoulder operations, you can use the caution mode or the straight line mode, the bar mode. Now, when I was at the city, I can tell you we didn't want to use the straight line arrow ever for caution. We would always use the 4 corners. Why do you think that is? Well, that's because sometimes crashes occurred where, well, especially mobile operations. When people see the straight bar, sometimes they actually think to themselves, well, look at these guys, they're out here working, and all the bulbs in the head of the arrow are burnt out. So they assume that you actually meant it to be the arrow mode, and they go around your work zone without slowing down at all, and then they can get into a crash that way. So when you use the 4 corners, that takes away that confusion. So that's something to think about. Okay, so if we're working on a 2-lane roadway and we need to close a lane, the way we do that is it's got a different type of taper, the 2-way traffic taper, the one we use in flagging. So it is shorter than the other tapers, and it also has more cones in it for each foot of length there is. The cones are closer together. And the reason why is because we want to create the illusion for the approaching traffic that they just see a wall of cones there. That's what it's supposed to look like from a distance. And so this encourages the drivers to slow down just by itself. So here we have a flagging operation, and we see the taper here. It's a shorter taper, and even the chart on page 17, you'll see that it has its own line in that middle table where it shows the spacing of the cones. So the cones are 20 feet. The maximum spacing is 20 feet apart. So, and typically you'll see the length of this taper is 50 feet to 100 feet. And that's it. If we compared that to a merging taper at 55 miles per hour, it would be 500 feet long, 495 feet long. But big difference between flagging and closing a lane on a 4-lane roadway. So here's some pictures of a the two-way traffic taper in the field. Picture on the left, you can tell it's an older picture with the older style of cones, and it's in the shade. That's not very good, right? A motorist might not even see those cones from a distance. So, but they would see these cones here on the right. So that's more like what we're shooting for. You can see the brand new cones close to pretty tight together. And so that's what we want to see in a flagging operation. Another thing to think about on these two-lane roads is where do you put the taper? So as you can see in this picture, the crew is working here around a curve, but they mistakenly put their taper here and the flagger standing here around the curve. That's not good. Whether this is a horizontal curve like you see here or a vertical curve, uh, the flagger and the taper should be over here towards the left before the curve. Very important. And then we have another situation here, and this is typical application number 11 for lane closure on a two-lane road with low traffic volumes. So a lot of county and township roads have this situation. So if you're in a situation here where there are no hills and curves, it's a nice straight stretch of road and it's low volume, then you can get by without using a flagger. You can do that with some signs. And this is a situation where maybe some of you that work at the county or a township are kind of chuckling because you're like, "Oh, we're never going to put all those signs out." Well, I'm not talking about a short, 15, 20, half hour type of job. We're talking about a job that might last all day or something. Definitely more than an hour. You might be in that spot. It's then that you want to think about using these signs. If you're only going to be out there for a short period of time, then you might want to just stick with the flaggers. But this would be more long term. I know, like right now, for instance, down in Pike County, County Road 66, Germany Road, they've had a lane closure for 3 years now. But this is the permanent setup of the work zone over that last 3 years. They have the road work ahead, one lane road ahead. They have the yield ahead sign, and then the yield. So that's been that way for over 3 years now. But again, that's because it's low volume. Okay, what else? Then we have a lane closure on a minor street. So here we have a situation, might be a low speed, low volume residential street, hardly any traffic during the day, everybody's at work. Maybe all you need to do is put out this sign here. See, it's the symbol of the man with the shovel sign, and some cones. So you don't need an elaborate work zone setup in that situation. All right, so then we have some intersection work. So here's a right lane closure on the far side of the intersection. And so in this situation, we've got your advanced warning area is here on the near side of the intersection. And then like I talked about in part 1, sometimes we need to use regulatory signs to communicate to the motorists exactly what we need them to do. Sometimes our orange signs just aren't enough. So here we have a combination of our orange signs and regulatory signs to get traffic to understand that if they're in the right lane, the northbound right lane, if they want to go straight through the intersection, they need to get over into the left lane. And if they stay in that lane, then they have to turn right. So this right lane must turn right. So the combination of these signs plus the arrow panel on the far side really that sends the message that they need to get over if they're going to proceed through the intersection. And if you look at all the traffic from all the other directions, they're not really affected by this. So all they get is a road work ahead. We want them to know that there is road work going on in the area, so be on the lookout. But they still can make all of their movements that they're used to moving. Okay, so what time is it getting to be? It's getting to be kind of late, isn't it? So this might be a good spot for us to end today's session. So we've completed the advanced warning area and the transition area. And so when we come back this afternoon, and what time do we start? Did you find that out, Paula?
It is 1 o'clock.
Okay, yeah, I didn't want it to be any confusion. So class starts at 1 o'clock today for part 3, and we'll begin as we speak about the work area, which consists of the buffer space and workspace. And then do we have another question we want to end with? Let's see. Okay. Cones in the center lane. Okay. Another thing I wanted to talk about this as I have another minute is I go back to this picture. It's important that when we deal with intersection work, and we'll talk more about that later, but there's different ways to handle this situation. And so that's why it's important to not only look at the picture, but to read the notes page. And so there's another way to handle this by creating a right turn pocket with cones before this. And you might need to have different signage to do that. So when we talk more about intersections, we'll see that there's some more thought that you can put into this to make things more safer and more efficient, depending on the particular traffic volumes and turning movement volumes at each intersection you're working at. So that's the thing we get into talking about intersections. Okay, so that's all I have. Is there anything else, Paula, before we break for this session?
Nothing on my end, and there are no questions in the questions pod.
All right. Well, everybody, I appreciate you taking the time to go through this with us today. And everybody take a nice long lunch, and we'll be back here at 1 o'clock for part 3. All right. We'll see you then. Bye-bye.